Okay, we're in section 10 of the notes. We've completed this section. It's on polynomial division. We presented two types and the methods to do those two types. The first type was a simple division when the divisor is a monomial. The other type of division that we do is when we have a binomial divisor, and currently that can be extended to trinomial divisors and so forth and so on. So we went through examples. Again, the first example was a monomial divisor. The second example, monomial divisor. Then we had a binomial divisor. We went through that in class. Again, for the students that are, maybe not paying attention, there's little tiny spot videos on the side that you can rewatch those videos if you like, or watch the whole lecture again. Again, a divisor, binomial. It's not a simple division, it's a long division. Binomial, again, it's not a simple division, it's a long division. A little more complicated one. They tell you what the polynomials are, and they tell you that it's a division problem. And what's Q? Well, Q, again, a binomial. It's a binomial divisor. Binomial divisor, binomial divisor. All right, now this can be extended to trinomials, so forth and so on. Where are we now? We're at the homework. The hope is this, that you've studied what we presented to you, you've made sense out of the material, and that you're ready to do these on your own. I'm going to go to the whiteboard though. So I'm going to share another screen with you. Okay, you're seeing a whiteboard now. And on the whiteboard, what we're going to do is I'll tell you what section of the notes we're in. Just give me 1 second here. Okay, we're in section 10 of the notes. And we're doing the homework. Now, the expectation, again, is you've done this already, that you're just watching this to see what I would do to do with the homework. And I might get stuck in a few problems, whatever. Can't hurt to watch it again to reinforce it. Number one, what I notice is they want me to divide it, and I have a trinomial on top of degree 6. I'll write that down for you. The divisor is a monomial. This is one term on the bottom. So what I'm going to do here is divide the terms on top by x squared. And what does this give us? Well, the first term would be x6 divided by x squared. 2 factors would cancel off. You'd be left off with 4 factors of x. Minus, well, I see a 3, and then I notice the x's. There's 4 factors on top, 2 on bottom. 2 cancels off, left off with 2. Minus, well, x squared is divisible by x squared. It would give you 1. By the way, these may be conditionally true statements. We're not worried about the conditions at this point. What you're going to do now is look at the answer key to verify that this is the same answer. And I'm looking at it, and it's the same answer. All right, let's go to number 2. Again, the hope is that you've done these already and that this is not going too quick for you. If you haven't done it already, though, and you haven't studied the material, that's what you need to go back and do. Let's read 2. 2 is also a division problem. It says divide. We have a trinomial on top of degree 2, and we're dividing by a monomial on the bottom. So our method is going to be this. We're going to take each term on top and divide it by 15x. All right, let's do one at a time. Now, the first one, it does reduce. That's all we're looking for. 3 goes into 3 once. It goes into 15 5 times. And certainly x squared divided by x, one of the x would cancel off, left with an x on top. Minus, well, 5 goes into 5 once and goes into 15 3 times. All right. The x's cancel off, it reduces to 1. Okay. Plus, what do you get there? Well, I'm looking at the 6 and 15, and they have a 3 in common. That would be 2. That would be 5. Let's look at the key. And again, I really emphasize this. It's something that you want to be doing on your own. and see if I got it right. X over 5 minus 1/3, 2 over 5x. Simple divisions tend to be really simple, and that's why we call them simple. All right? If you need additional help, though, if things are confusing you, please come by during office hours. We're on number 3 now. I'll write it down for you. It's 2x squared minus 13x plus 21, and I'm dividing by x minus 3. All right, what's critical here is that you start to realize this is a division problem, but the divisor is not a monomial, it's a binomial. So we're going to write down long division. So it's going to be x minus 3 is going to be divided into 2x squared. This is a trinomial degree 2. What's critical here? You need to find a multiple of this, that's x, that would match 2x squared identically. Well, that multiple tends to be quite simple. It's just simply 2x. I put this in the column of x's. Now what you're going to do is distribute the 2x across these two terms and write it down here. Let me do that for you. That would give you 2x squared minus 6x. Our recommendation to you is just to subtract. What we do notice, though, a lot of students struggle with that. So what I'm going to do is I'm going to change the signs. Let me do that for you. So the 2 is a positive, so I'm going to change it to a negative. This, minus 6x, if I change the sign there, it would be plus. So change the signs and combine. And what would you get over there? Well, the x squareds disappear because 2x squared minus 2x squared is 0. And minus 13 plus 6 is going to be minus 7x. Now we're going to drop down to 21, and we're going to repeat it. Repeat what? Multiple of this. That would match this minus 7x identically. What would that be? Minus 7. Let's write that down. Distributive property multiplication. This minus 7 is distributed across these two terms. And what do you get? Minus 7x plus 21. Again, my recommendation is subtract, but a lot of students have trouble with that. So what I'm going to do, change the signs. So this becomes plus, this becomes minus. All right, now if you did that, what would you get? Minus 7x plus 7x is 0, and 21 minus 21 is 0. No remainder. So my answer here is 2x minus 7. Put that in a box. That's a result of division. By the way, this is conditional. We're not worried about what the conditions are at this point. What am I going to do here? Recommend you look at the answer K to see if you're staring at that. And we certainly are. All right, let's go to number 4. Again, these are relatively simple problems if you've studied. If you haven't studied, though, everything's going to be confusing to you. So number 5, I'll write it down for you, is going to be, whoops, did I say 5? I skipped 4, didn't I? Yeah, I'm sorry. Go back to 4. Get my eraser out. I'll put 4 down now. Sorry about that. So what I'm going to do is I recognize that 4 is a long division problem. I'm going to write it down for you. I'm not going to write the problem down. I'm just going to write the long division down now. 3x plus 4. That's a binomial divisor, and it's being divided into this trinomial, which is degree 2. What am I going to do? Well, my recommendation is this. What multiple of 3x would match 15x squared? Well, that's relatively simple. It's 5x. What's 5x times 3x? 15x squared. We're using the distributive property of multiplication. What's 5x times 4? 20x. All right, what am I going to recommend? Changing the signs and combine for those students that have trouble with the subtraction. Let me do that for you. Change them. All right, let me do it. What do you get there? 15x squared minus 15x squared is nothing. And 17 minus 20 is going to be minus 3x. Drop the place down. The place is minus 4. What do I do now? Same story. What multiple of 3x would match this thing, minus 3x? Well, that's simple. It's minus 1. What do you give it there? Minus 3x minus 4. What am I going to recommend? Change the signs. So this would be plus, this would be plus. What do you get there? Well, minus 3x plus 3x is 0, and minus 4 plus 4 is 0. No remainder. What's my answer? 5x minus 1. Let me look at the key, see if that's what I'm staring at, and that's exactly what I'm staring at. I'm going to go on number 5 now. And something we recommend in class is, certainly rewriting the problem, certainly. What's a divisor? It's binomial. Now, what do I notice about this second degree polynomial? It's missing the next term, which is going to be degree 1. So I'm going to put down there's no x's there. Now, something said, do I need to do that? Well, a lot of students do, but I'll be honest with you, you don't have to, but it's a good idea to have the places held. Let me point out what I mean by there. Squares, one factor, no factors. Well, what am I going to do now? What multiple of x would match 2x squared? Well, that's simple. It's 2x. You notice there's a column of x's now to put that down. So what do you get over here? 2x squared minus 6x. My recommendation for the students struggling with long division is to change the signs. All right, what do you get over here? Well, 2x squared minus 2x squared is nothing, and 0x plus 6x is 6x. What am I going to do now? Same thing over and over again. What times x would match 6x? Well, that's quite simple. It's plus 6. So what do you get here? 6x minus 18. What's my recommendation for the students struggling with subtraction? Change the signs and combine. And what would you get there? Well, 6x minus 6x is nothing, and 7 plus 18 is 25. Okay, we have a remainder now. I want to be honest with you. The division could continue. We could divide x into 25, but we don't at the mth100 level. So what we're going to do is we're going to say we're done. We're going to say 2x plus 6 plus something I didn't finish. I did not finish dividing 25 by x minus 3. I'll put this in a box. All right, I want to get my little answer key out. I'm looking at it, and I'm seeing the 2x plus 6 plus 25 over x minus 3. We're done with that. Let me go to number 6. And again, these should be relatively simple questions. And what do I have here? Well, this is the first time I'm seeing this. I'm seeing a trinomial divisor. I'll write this down for you. And I realize for some students, this might seem like an overwhelming problem to do. I want to assure you, we do not give overwhelming problems. Now, what do I notice over here? It's 8x cubed, but there are no square terms. There are no linear terms, but there is a constant term, minus 27. Again, the big question students often ask, do I need to write down those missing terms? No, but I think it's a good idea at this level. So what I'm going to do now, what multiple of 4x squared would match 8x cubed identically? Well, that's pretty simple, and typically we make the number simple for you. What's it going to be? Well, it looks like 2x. Did I copy this problem? Yeah, 2x. Let me write this down for you. What do you get? 8x cubed plus, I'm using the distributive property multiplication. 2x times 6x is 12x squared. And then 2x times 9 is going to be 18x. Now, what do we recommend? Certainly, I recommend subtraction, but a lot of students struggle with that. So I'm going to change the signs. And what do you get? Well, 8x cubed minus 8x cubed is nothing. 0x squared minus 12x squared is minus 12x squared. 0x minus 18x is minus 18x. And then drop the place down, minus 27. All right, what are you going to do now? What multiple of 4x squared would match minus 12x squared identically? Fairly simple. It's going to be minus 3. Let's go through that. Distributive property. Minus 3 times 4x squared, minus 12x squared. Minus 3 times plus 6 is minus 18x. Minus 3 times 9, minus 27. Again, we recommend subtraction, but a lot of students struggle with that. So we say change the signs and combine. And what do you get? 0. So what's my answer? 2x minus 3. Let's check it in the answer key. And what's the answer key say? 2x minus 3. Now, for students on exams where they don't have an answer key, you could actually check this yourself. I'll write down what the check looks like. We're going to check that 4x squared plus 6x plus 9, something you did in grade school with numbers, 2x minus 3 would equal 8x cubed minus 27. Let me just quickly go through that to multiply it out. And I'm going to multiply it. And so how are you going to multiply it? Well, I'm going to be taking the 2x and distributing across those three terms. I'll write that down for you. It's going to be 8x cubed plus 12x squared plus 18x. Then I'm going to distribute the minus 3 across those three terms. What do you get? Minus 12x squared, let's see, minus 18x minus 27. And then I would combine them together. And what do you get? 8x cubed, right? Well, geez, minus 27. Lo and behold, exactly what we expected it to be. Again, when you're doing homework, check with the answer key, but you realize you could still check these without having an answer key. Right, let's go to the next one, which would be number 7. And let's put that one down. Oh, another trinomial divisor. Write this down. X squared minus 4x plus 3. And it's being divided into 4x cubed minus 14x squared plus 2x minus 7. Well, I'm looking at it. Again, it's a matching game. You know, what times x squared? What times x squared match this thing over here? Fairly simple. What's that going to be? Well, that would have to be 4x, right? And what do you get there? 4x cubed minus 16x squared. I'm using the distributive property of multiplication. And 4x times 3 is plus 12x. Again, we recommend you subtract. A lot of students struggle with that. So we say change the signs. And what do you get? Well, looking at it, you get 2x squared. And then you get minus 10x. Drop a place down. And let's take a look at it. And the big question is, what times x squared matches this, which is 2x squared? Well, that would have to be 2. What do you get? 2x squared minus 8x plus 6. Let's change our signs and combine. And what do you get there? Minus 2x. And that would be minus 13. All right, let me write the answer down. I'm going to write a variety of answers down, but I'm going to put the simplest one down. 4x plus 2 plus something I didn't finish. I didn't finish dividing 2x minus 13 by x squared minus 4x plus 3. This is an acceptable answer, all right? I want to point out that a lot of people don't like writing that down because it looks very strange to them. So what they do is they write this one down instead. Minus. Now what are they doing there? They're factoring out a negative 1 from that. What would they be left off with? 2x plus 13 over x squared minus 4x plus 3. Once I put something in a box, though, I'm saying it's acceptable. Now, certainly, I make mistakes. Let's take a look at the answer key and see how we've done over there. So I'm looking at it, and I'm seeing the 4x plus 2 minus 2x plus 13 over x squared minus 4x plus 3. Looking good. All right. Again, for students struggling, I want to recommend you come by during office hours, and we'd be more than happy to help you one-on-one. All right, let's go to number 8. And number 8 says, you know, do some divisions. And I want to be honest with you, for a lot of students, this is difficult, all right? And it's abstract form. But I'm going to put x minus y, a little more difficult. It's a binomial. And I'm going to write this down, x squared minus y squared. So sometimes I say, oh, you don't have places to hold. And this is why, you know, a lot of students don't like putting down places. They don't know what the missing places are. All right, but let's write this down. And I'll tell you what I'm doing over here. I'm looking at x, and I'm saying, what times x would give me x squared? It's got to be x. Now, what do you get? X times x is x squared, right? And x times minus y is minus xy. All right, what do we do now? Change the signs and combine. Well, let's do that. What do you get? The x squared has disappeared. Then what are you left off with? Xy minus y squared. Let's keep going. And I'll talk about what I need to do over here. What times x would match xy identically? Well, I'm going to say y. And what do you get? xy minus y squared. Now what do? Change the signs and combine, and what do you get? 0. So my first answer, pretty simple, x plus y. This is A. Let's go to B. Little more difficult. All right, let's put B down. And what do you see? X minus y is being divided into x cubed minus y cubed. Well, same story, and I'll tell you what that story is. What times x would match the x cubed? That's x squared. You would get x cubed. Whoops, that doesn't look like cube, does it? Minus x squared y. Change the signs and combine. And what do you get? X squared y minus y cubed. You're going to keep repeating. What times this? Whoops. What times this would match this identically? Well, it has to be plus xy now. I know this is difficult. X squared y minus xy squared. What are you going to do now? Change the signs and combine. Let me push this up. And what are you going to get over here? Well, let's see. You're going to get xy squared minus y cubed. And yes, I know it's difficult. All right. What times this would match this identically? Well, I'm going to say plus y squared. What do you get there? Xy squared minus y cubed. All right. Change the signs and combine. And what do you get? You get 0. I have this result. All right. I'm going to shrink this down a little bit. I notice there's sort of like a pattern going on there, but I'm not saying, I know the pattern yet, but it seems like there's a pattern problem to this. All right, let me keep going. And the next one, I'm going to do C now. And C is x minus y. Again, some people don't see patterns, and that's fine. Whoops, I went too long there, didn't I? That's going to be x4 minus y4. Well, I've been doing a lot of divisions, and I think I'm getting better at it. And I'm going to not use red ink in this one. I'm just going to go through it. So x cubed, that would give me x4 minus x cubed y. If I subtract that, I would get x cubed y minus y4. And what do I get? Plus x squared y. What does this give me? X cubed y minus x squared y squared. I'm going to subtract. I'm going to keep going. And I'm going to say what gives me that is plus xy squared. That would give me x squared y squared. Whoa, minus x y cubed. What does that give me? X y cubed minus y4. And then I'm going to do it again. Keep going. I get plus, I guess I need y cubed there, right? And what do you get over there? X y cubed minus y4. Subtract to get 0. So I got some interesting patterns over here. All right, so I'm going to write them down for you. All right, I'm going to write everyone down. So I'm going to write down A, I just did it, and x squared minus y squared over x minus y was equal to x plus y. And then B was x cubed minus y cubed over x minus y equals x squared plus xy plus y squared. And C, we just completed it, was x4 minus y4 over x minus y. Which would the same problem over and over again, it seems, was give me x cubed plus x squared y plus xy squared plus y cubed. Now, by the way, when I say there's a pattern, I really believe there's a pattern to that. So if I wrote the next one down without doing division, or what I said the next one, x5 minus y5 over x minus y, what would I see? I want to point out what I think I'm seeing. I'm seeing x's. There's 3, 2, 1, none. 3, 2, 1, none. Then I see the y's, 3, 2, 1, none. Well, I think I can write this down then. And what would I write down? X, 4, X, 3, X, 2, X, 1, and then X, none. Let me start doing the y's then. Y, 4, Y, 3, Y, 2, Y, 1, and then Y, none. Very simple pattern, by the way. All right. So what do they ask me in D? They say, can you do this without doing the division? And I think we can, right? By knowing the pattern. Yeah, let me write this down. This is D. And they got X10 minus Y10 over X minus Y. Well, I'm going to claim I think I can write it down. X9, X8, X7. Well, it's going to be a lot of writing, isn't it? X6, X5. Wow, I'm running out. X4, X3, X2, X1, and then X none. Now we're going to do the Y's. Y9, Y8, Y7, Y6. Let's see, 5, 4, 3, 2, 1, and then none. So I'm going to claim that's the answer. Let's see if we got it right. What am I going to do? Look at the answer key. I'm trusting it, by the way. 6, 3, 5, 4, 4, 5, 3, 6, 2, 7, 1, 8. Wow, not bad. All right, what am I going to do now? Go to Sage. Give me 1 second. And we're going to Sage now. Just give me 1 second, make sure I did that. Yeah, so related Sage code. Somebody said, do I really need to do this? No, but it's nice to think about options. And the more options you have, the better. And coding is an option for you. I'm not saying you need to take it seriously. We're not going to test you on it. I'm going to click on this, though. And that's when those things were in the, so I got that reddish color, it'll open up the link. Now, this link happens to be a website, sagemath.org. It's going to bring you there. And what I'm going to recommend here, as I've been doing all along, is not to download the software, although you could. But I know from experience, even my upper level students have a tough time installing software. So what I'm going to claim over here is that you use the web-based application. That's called CoCalc. CoCalc will open. And when CoCalc opens, it's going to launch like this Sage Math server. So I'm going to, start a project, and it's starting. It takes time, and the reason for that is it's trying to get a computer free to give me a resource to do the computation that I want to do. I like using a clean sheet of paper. I got a lot of pieces of paper down over here. They're not clean. I'm just going to start a new notebook here. All right, it gives me a title. Don't worry about that. We're not saving these things or submitting them. Sage worksheet. That's what I want to do. I want to create a new Sage worksheet. Just click on it. And then what's going to happen is like a blank piece of paper is going to open. All right. I realize there may be some things in the paper you don't understand, but the bottom line is like any document, there's a lot of things going on there. What do I want to do though? I want to type in this stuff. And whoops, I'm sorry about that. So I want to type in reset. Now, what does reset do? It kind of clears the memory out. If there's anything left over, it's going to clear it out. Now, if you hit return, nothing's going to happen. But if you hit shift return, it's going to execute the command. I hope you notice the difference over there. It's got this green thing now. What does it says? I just did this. I reset it for you. I'm going to say X is a variable. This is typical in computer science. We define variables. I'm just simply typing what I see. Remember, shift return to execute the command. Let's keep going. And let's see what they give us. Okay, f of x. I'm going to say, f is a function of x. The equal sign is an assignment operator. So I'm assigning to that f of x squared minus x minus 6, and then I'm going to divide it by x minus 3. And then hit shift return. Now I'm going to display f of x for you. And what does it give me back? Exactly what I typed in, x squared minus x minus 6 divided by x minus 3. Now here comes something tough. I'm looking at it. I'm wondering what it does. I'm going to write down f of x. Whoops, made a mistake. I'm just copying the code. Simplify. You see that? Rational. Now, someone says, why do they call it rational? It's a ratio of two polynomial. This is a function call. I know that sounds like a big word to you, but I'm calling a function in Sage. It's a Python function that's going to attempt to simplify that rational f of x. Let's see if it does. It's working on it. X plus 2. That's not bad. What do you think it did? Well, you might say, oh, I think it did long division. It might have done something different, but we've done that problem, and we got x plus 2 by long division. All right, I'm going to go through the next one. I'm going to write down another function, and this is going to be g of x, and g of x is being assigned 6 star. Remember, you need to use multiplication symbol star in Sage, otherwise we won't understand it. Let's see, minus x, minus 15, and then we're dividing by 3 star x minus 5. I guess if I make a mistake, it'll say I made a mistake. Let me just type in G, see what it says, see if I typed it in right. And it says 6x squared minus x minus 15 divided by 3x minus 5. All right, so let's take a look what they give me over here. And I'm going to see if what it does for me. And someone says, if a machine could do it, why do I need to learn? You need to learn to do simple things. Machines could be really relegated to doing more difficult things, but we're learning at this point. We're learning how a machine relates to the code we've already done in class. So same thing I've done before, right? So simplify the rational. All right, it's a function call. It's a Python function call, 2x plus 3. We've done those before. Now you may want to start, playing around with the problems that we've just done. For example, let's go backwards. All right, and let's try this one. All right, let's try it. Now someone can say, I don't think I could do it. It's just too difficult. I don't know. Let's give it a shot. And I'm gonna reset. Now if I can't remember, I can always look back over my notes. I want to define a variable x and y this time. And by the way, I'm not sure if it can do it. Maybe it says it's too tough for me. All right, and then I'm going to say, let's see, let's write this down. X to the 10th power minus y to the 10th power divide by x minus y. And what do we want to do? Simplify. Now I realize somebody said, I don't think it's a simplification at all. It is. If we can take something that's rational, wow, look at that, how fast that was. And let's just make sure it gives them the same answer. X8, X9, X8, X7, X6, X5, X4, X3, X2, X1, X9, Y9, Y8, Y7, Y6, Y5, Y4. I'm just counting it, Y3, Y2, Y1, Y9. It's the same answer. Right, really important. Right, you could play around with that. I mean, you could take this thing over here, recopy it, and you probably could say, I wonder if I gave it something really difficult, like let's do this one over here, 25. I think you get the idea, right? Wow, look how fast it did it. That's amazing. Right, exactly what we expected, the same pattern over and over again. All right, that's about it. Good luck.